Tonight, we begin in a place that costs nothing to visit, and yet contains everything we have ever known. Before we go any further, if you want a brand new space topic every single night to fall asleep to, subscribe. One tap and a new story is waiting for you every evening. We begin by looking up, not at a map, not at a screen, but at the night sky as it actually is, with its quiet scattering of pale fires and its long, patient darkness in between. The sky above us looks busy. Stars sprinkle the black like grains of salt on dark cloth. The faint band of the Milky Way stretches across the dome of night. A soft river of light made of countless suns too far away to see one by one. Planets drift slowly along their old paths. The moon, when it is there, hangs in silver stillness, scarred and beautiful and close. And yet, for all of that brightness, the sky is quiet. No signals, no greetings, no distant lighthouse blinking from another world, no fleet of ships moving among the stars, no structures around faraway suns that we can clearly see, only light and the long, soft hush of a universe that does not seem to be speaking to anyone. This silence is older than you. It is older than your grandparents, older than the first cities, older than the first words a human mouth ever shaped. As far as we can tell, the sky has always been this quiet. And tonight, gently, we are going to sit with one of the strangest possibilities that quiet might mean. What if we are the first? What if, in all this vast and slowly turning ocean of galaxies, no one has come before us? No earlier minds, no older civilizations watching from somewhere far away, no ancient ones who solved the problems we are only now learning to name. What if the universe, in all its long age, has only just now opened its eyes, and those eyes are ours? It sounds like a bold idea, almost too bold. And it may not be true. There are good reasons to think life is common, that minds are common, that we are simply too young or too deaf to hear the others. There are equally good reasons to wonder whether we really are early arrivals at a party that has barely begun. The honest answer, the answer the best thinkers keep returning to, is that we do not yet know. The question is open. It may stay open for a very long time. To feel the size of this question, picture the Earth from far away. a small blue world wrapped in thin white cloud, turning slowly in the black. Step further back until the sun itself becomes a bright point among many. Step further still until our whole galaxy is a soft spiral of light, a disk of stars and dust spinning in the dark like a slow pinwheel, and further again until that spiral is one of many, until thousands of galaxies drift past in clusters and webs, threaded along invisible rivers of gravity. Somewhere in that vast structure is us, one species, on one moist little planet, around one ordinary star, in one arm of one galaxy, in one quiet corner of a universe that contains more galaxies than there are grains of sand on every beach on Earth. And as far as anything has ever shown us, we are the only ones who have looked up and asked the question. That might be a trick of timing. We have only been listening for about 100 years. We have only known what galaxies are for about 100 years. Our search is a thin sliver of attention pointed at an ocean. Of course, it is mostly empty. Of course, we have heard mostly nothing. Of course. Or it might be something else. It might be that the universe is still young in a way that matters, that the conditions for minds like ours have only recently become possible, and that when we listen to the silence, we are hearing something true about our place in cosmic time. We may, quite literally, be early. Over the next many hours, we are going to walk slowly through this idea. We will look at the age of the universe, the long wait for stable galaxies, the slow build of the elements life needs, and the strange luck of our own small world. We will not solve the mystery. No one yet can, but we will sit with it together. For now, simply rest your eyes. Let the sky above us be quiet, and wonder softly what that quiet might mean. To sit with the question of whether we are first, we need to feel the weight of time. Not the time of a single life, or even of a civilization. The time of the universe itself. So let us begin with the simplest fact, and then let it grow slowly in your mind, the way a star grows from a quiet cloud of gas. The universe, as best we can measure, is about 13.8 billion years old. That number is so large, it almost slides off the mind. So picture it this way. If the whole history of the universe were squeezed into a single year, then humans, with our cities and our languages and our radio dishes, would appear in the final few seconds before midnight on December 31. Everything we have ever built, every story we have ever told, fits into that last quiet breath of the cosmic year. Earth itself is about 4.5 billion years old. That means our planet has been here for roughly a third of all time. The sun is about the same age, a middle-aged star drifting through the outer arm of a spiral galaxy we call the Milky Way. Before the sun was lit, the universe had already spent more than 9 billion years doing other things, forming galaxies, cooking heavy atoms in the cores of dying stars, spreading dust and ice and rock through the dark. Try to feel the shape of that. The universe lived 9 billion years without us, without our sun, without our earth, without any of the warm tide pools where the first cells may have stirred. And in all that long, unwitnessed time, something was either happening or not happening on other worlds. We do not know which. The universe is also very large. The part we can see, the observable universe, stretches about 93 billion light years across. A light year is the distance light travels in 1 year, and light is the fastest thing there is. Even at that speed, a single beam would need 93 billion years to cross from one edge of the visible sky to the other, if it could. Inside that vast bubble, astronomers estimate there are perhaps 2 trillion galaxies. Each galaxy holds anywhere from millions to trillions of stars. And around many of those stars, we now know there are planets. That last fact is fairly new. Only in the last 30 years or so have we confirmed that planets are common. Before then, we had to guess. Now we have counted thousands of them, and the count keeps rising. Some are gas giants hugging close to their suns. Some are small rocky worlds tucked in the gentle warmth where liquid water might pool. The numbers suggest that planets like ours, in orbits like ours, may exist by the billions in our galaxy alone. And yet the sky is quiet. That is the basic tension of our question. The universe is old. The universe is huge. Planets are everywhere. The ingredients for life, as far as we understand them, are spread through every corner we have looked. By any simple counting, there should be company. There should be voices, or at least echoes of voices. Instead, when we point our most sensitive instruments at the dark and listen, we hear only the soft hiss of the universe itself. One possibility is that we have not listened long enough, or in the right way. Another possibility is that life is common, but quiet, never building the kind of technology that leaves a fingerprint across the stars. And another possibility, the one this episode lingers on, is that we may simply be early, that the long 9 billion years before Earth was not wasted, but was the necessary patience the universe required before any minds at all could appear. These ideas all sit on the same table. None has won. The numbers are real, but the meaning of the numbers is still open. It helps to remember that we are very new at this. The first human to point a telescope at the sky did so only about 400 years ago. The first radio telescope listened in the 1930s. Our search for other civilizations is younger than many of the trees in old forests. We are a child standing at the edge of a dark ocean, having dipped one toe in and concluding nothing yet about what swims beneath. So, as you rest tonight, hold those simple numbers gently. The universe is 13.8 billion years old. Earth is 4.5 billion. The visible cosmos is 93 billion light years wide. Trillions of galaxies, billions of worlds, and one small species on one small planet, just beginning to wonder whether anyone is wondering back. The rest of this slow tour will sit with that wondering. For a long time after the universe began, there was no light at all. The cosmos was a warm fog of hydrogen and helium drifting in the dark. No stars, no galaxies, no worlds, just a soft sea of gas, slowly cooling, slowly thinning, slowly waiting. This quiet stretch is sometimes called the cosmic dark ages, and it lasted for many millions of years. To understand whether we might be the first technological civilization, it helps to picture this earliest darkness. The universe had to invent light before it could invent anything else. And light, as far as we can tell, came from the first stars. The leading idea is that gravity did the slow, patient network of gathering, tiny ripples in the early gas, places where matter was a little denser than average, began to pull more matter toward themselves. Over millions of years, those small lumps grew into vast clouds. The clouds collapsed inward under their own weight. At the center of each one, pressure and heat climbed until hydrogen atoms began to fuse. That first fusion was the first starlight the universe had ever seen. These earliest stars are called population 3 stars, and we have never directly observed one. Every star we can study today is younger, made from gas that already carries the ashes of older stars. The first generation remains a theory built from physics and simulation. Some researchers think these stars were enormous, hundreds of times the mass of our sun, blazing blue-white and burning through their fuel in only a few million years. Others suspect they came in a wider range of sizes, including smaller stars that might still survive somewhere, hidden in the outskirts of galaxies. The question remains open. New telescopes are searching for their faint signatures, but the evidence is still incomplete. What we can say is that these first stars changed everything. They flooded the gas around them with ultraviolet light. They cleared the fog. They ended the dark ages. And when the largest of them died, they died in spectacular collapses, scattering new ingredients into the void. Inside their cores, fusion had built heavier atoms from lighter ones. Carbon, oxygen, silicon, iron. These elements did not exist in the early universe. They had to be cooked inside stars and then released by stellar death. This timing matters when we wonder about who came first. Before the first stars lived and died, the universe simply did not contain the materials a planet like Earth requires. There was no rock, no metal, no water in any meaningful amount. A civilization could not have arisen in those early ages because the building blocks of biology were not yet on the shelf. The cosmos had to seed itself, generation after generation, before anything as complicated as a cell could even be considered. One way to picture it is to imagine a slow kitchen. The first stars were the rough first batch, producing a thin sprinkle of heavier atoms. The second generation of stars formed from that slightly enriched gas. And when they died, added more. Each round of star birth and star death raised the chemical richness of the universe by a small amount. It took billions of years of this patient cooking before any region of the cosmos held enough heavy elements to build rocky planets in abundance. Some thinkers point to this slow chemistry as a reason we might be early rather than late. If the universe needed many cycles of stellar life and death before planets like ours became common, then the window for technological civilizations may have only recently opened. One model, sometimes called the grabby aliens idea, suggests we are arriving near the beginning of a long era when minds become possible. A competing view holds that the conditions for life have been ready for many billions of years already, and that countless civilizations may have come and gone before us. Both pictures fit the evidence we have. Neither can be ruled out. So we sit with a strange thought as we look up at the night. The light reaching our eyes comes from stars that are themselves the descendants of older stars, each one a quiet contributor to a long chemical inheritance. The universe spent its first ages with no observers in it at all. Then, somewhere along the slow climb from dark gas to glowing galaxies, the materials for thought began to gather. Whether we are among the earliest minds to look back at this story, or one of many who have done so before, no one yet knows. The first stars are gone. The first questions, perhaps, are only beginning, and the cosmos continues its long, unhurried work, cooking new elements in the hearts of newer suns, somewhere out there in the dark. Think for a moment about your own body resting there in the dark. The calcium in your bones, the iron in your blood, the oxygen moving through your lungs. None of these things existed when the universe began. They had to be made, and the making of them took a very long time. The early universe was a simple place. After the first heat faded, the cosmos held mostly hydrogen and helium, with just a faint trace of lithium. That was all. No carbon, no nitrogen, no oxygen, no silicon for rock, no iron for cores, no phosphorus for the long chains of life. The periodic table, as we know it, simply did not yet exist. The universe had to build itself, atom by atom, inside the hearts of stars. When the first stars formed, they began the slow work of fusion. They pressed hydrogen into helium, then helium into carbon, and carbon into oxygen. Inside the largest stars, the work climbed higher still, all the way up to iron. And when those massive stars ran out of fuel, they collapsed and exploded, scattering their newly forged elements into the dark. Each supernova was a kind of seed, spreading metals across vast clouds of gas. Then those clouds collapsed into new stars, which lived, died, and seeded again. Generation after generation, the cosmos grew richer. The iron at the center of Earth, the iron at the center of you, was forged in the cores of stars that died before our sun was born. The gold in a wedding ring may have come from something even rarer. One leading idea is that much of the heaviest material, including gold and platinum and uranium, formed when two neutron stars collided and tore each other apart in waves of radiation. Other researchers wonder whether certain rare supernovae also contributed. The exact recipe remains an open question. What seems clear is that these elements are not common, and they took a long, long time to accumulate. This slow enrichment matters deeply to the question we are sitting with tonight. A planet like Earth needs more than warmth and water. It needs a rocky body with a metallic core, a magnetic field, a crust full of useful minerals. It needs the building blocks of biochemistry, the carbon and nitrogen and phosphorus that life weaves into long, delicate molecules. For most of cosmic history, these ingredients were too scarce. The early galaxies were thin soups of light gas with only faint traces of metal. A rocky world like ours could not easily form there. Some researchers think Earth-like planets only became common a few billion years before our sun ignited. Others suggest the window opened a little earlier, in pockets of the galaxy that were enriched faster than average. The answer depends on details we are still measuring. The question of when habitable planets first became possible is not yet settled. There is one more piece to this puzzle, and it is a soft and strange one. The water in your glass, the water in every ocean, may not have been born on Earth at all. The young Earth was hot and dry, many scientists think much of its water arrived later, delivered by icy comets and water-rich asteroids that fell from the outer solar system. Other researchers argue that a great deal of water was already locked into the rocks from which Earth formed, released slowly as the planet cooled. Both ideas may be partly true. The mystery of how a dry world became a blue one is still being worked out. What this means is that every drop of seawater, every breath you take, every bone in your body has a long cosmic history behind it. The atoms inside you were scattered across many stars, drifted in dark clouds, fell as ice into a young planet, and then climbed slowly upward through plants and animals until they became part of a thinking mind. You are, in a real sense, very old material arranged in a very new way. And this is part of why the question of being first feels so heavy. If the heavy elements only became common in recent cosmic time, then complex chemistry, and therefore complex life, may also be a recent phenomenon. Perhaps the universe simply was not ready to grow minds like ours until quite lately. Perhaps we arrived as soon as we possibly could. Or perhaps the ingredients have been ready for billions of years, and we are simply among the early bloomers. There is no way yet to know which picture is true. So as you settle deeper into the quiet, let your thoughts drift back along the long chain, from the first hydrogen through dying stars, through colliding remnants, through comets and oceans and slow green forests, all the way to the warmth of your own resting breath. Everything links. Everything took time, and the time, perhaps, was only just enough. Long before any planet could hold a thinking creature, the young universe was a restless place. Galaxies were not the calm pinwheels we see today. They were small, bright, crowded things crashing into each other in the dark. To understand why we might be early, we have to picture the forces that slowly tamed them. Gravity, radiation, magnetic fields, and the great pressure of exploding stars all worked together over billions of years. They built the quiet shelves of space where life could finally take hold. In the first few billion years, gravity ruled with a heavy hand. Clouds of gas pulled themselves into clumps. Those clumps pulled on one another, small galaxies fell into larger ones and were torn apart. The night sky of that era, if anyone had been there to see it, would have shimmered with collisions. Stars formed in sudden bursts, then died fast and loud. Their light filled the spaces between in waves of harsh radiation. This radiation mattered more than it sounds. Young, massive stars give off fierce ultraviolet light and powerful winds of charged particles. In a crowded early galaxy, this output was constant. It could strip the atmospheres from young planets. It could sterilize warm surfaces before any chemistry had time to settle. Some researchers wonder if the early universe was simply too loud in this radiation sense for fragile biology. Others argue that quiet pockets existed even then, shielded by dust or distance. The question stays open. Then there were the gamma ray bursts. These are sudden, blinding flashes thought to come from the deaths of certain massive stars and the mergers of dense stellar remnants. In the early universe, with so many young stars packed close together, such bursts may have been more frequent. One idea suggests that nearby gamma ray bursts could wreck a planet's protective ozone, exposing any surface life to deadly radiation. If this were common, then the inner regions of young galaxies might have been hostile for a very long time. A competing view holds that life can rebound quickly after such events, or hide in oceans and ice. Nobody yet knows which picture is closer to truth. Magnetic fields played their own quiet part. Galaxies are threaded with vast, faint magnetic lines woven through clouds of gas. These fields guide the flow of cosmic rays, the high-speed particles that race between stars. A young, turbulent galaxy has tangled fields and stronger cosmic ray storms. As galaxies aged and settled into smoother shapes, these fields organized themselves. The storms grew gentler. The space between stars became a calmer ocean. Whether life needed this calm to begin, or whether it could have started in the storm, remains an open puzzle. Tidal forces also shaped the long wait. When two galaxies pass near each other, gravity stretches them. Stars get flung onto wild new paths. Gas clouds get squeezed, sometimes hard enough to ignite huge bursts of new star formation. A planet caught in such a galaxy might find its night sky changing every few million years. Its sun could be pulled into a new neighborhood, closer to dangerous regions or farther from them. Only after the great mergers slowed did stars settle into the long, steady orbits we now consider normal. Our own sun moves through a fairly quiet part of the Milky Way, far from the crowded core. Some researchers think this calm location is part of why we are here. Others suspect quiet zones existed earlier than we assume. Pressure from supernova explosions added another layer. Each dying massive star sends out a shockwave that compresses nearby gas. This can trigger new stars to form. It can also blow gas right out of small galaxies, robbing them of the raw material for future suns. Over billions of years, this push and pull slowly balanced. Galaxies that survived grew large enough to hold onto their gas. They became the steady star factories we see today. Smaller galaxies often went quiet, their building material lost to the void. Put all of these forces together, and a picture takes shape. The universe needed time to cool down, to settle, to grow patient. The wild early galaxies had to mature into the gentler spirals and ellipticals we know. Only then could long-lived stars shine in peace for billions of years, giving any nearby world the steady warmth it might need. One possibility is that this settling finished only recently in cosmic terms, perhaps a few billion years before Earth formed. Another possibility is that calm pockets existed much earlier, and we simply have not found their traces. Either way, the long wait for stable galaxies is part of why the question of being first cannot yet be answered. The stage took a long time to quiet itself. Numbers can feel cold when they grow too large. Billions and trillions blur together until they lose all meaning. So tonight, let us try something gentler. Let us shrink the universe down to a size the mind can hold and place ourselves inside it and feel how strange our moment really is. Imagine the entire history of the universe stretched across a single calendar year. The Big Bang happens in the first second of January. Each month of this imagined year covers a little over 1 billion years of real time. Each day covers about 37 million years. Each second is roughly 430 years long. The whole cosmic story, from beginning to now, fits inside 12 quiet months. On that calendar, the first stars do not light up until late January. Galaxies take shape through February and March. Our Milky Way begins to settle into its spiral form around March or April, though its full assembly takes much longer. Most of the year passes with no Earth at all. No sun, no solar system, just generations of stars living, dying, and seeding the dark with the heavier stuff future worlds will need. The sun finally ignites in early September. Earth forms shortly after, a hot ball of rock that knows nothing yet. Single-celled life appears in late September or early October, and for almost the entire rest of the year, life stays small and quiet. Tiny cells drifting in shallow seas. No bones, no leaves, no eyes, just slow chemistry repeating itself for billions of years. Complex animals do not show up until mid-December. Dinosaurs walk the earth on Christmas Day and vanish on the 30th. The first members of our own genus appear in the final hour of December 31st. All of recorded human history, every pyramid and pottery shard and written word, fits inside the last 14 seconds before midnight. The industrial age, the rockets, the radio signals leaking out into space, the entire span of what we might call a technological civilization, fits in the last quarter second. That is our scale. A quarter second of awareness inside a year-long story. And the story itself, the cosmic year, is only just beginning. Try another comparison. Picture the future of star formation as a road stretching out ahead of us. The road is roughly 100 times longer than the road already traveled. If the past of the universe is a single step you have already taken, the future is 100 steps still waiting. We are not at the middle of the journey. We are not even near it. We are standing somewhere very close to the trailhead, looking out at a path that runs almost beyond imagination. This is part of why the question of being first cannot be dismissed easily. Someone has to stand near the beginning. Someone has to be the early bird in any process that unfolds across trillions of years. The puzzle is whether that someone is us, or whether the cosmic morning is already crowded with quiet minds we simply cannot see. Shrink the scales differently, and the strangeness only deepens. If the sun were the size of a basketball sitting on a table in front of you, Earth would be a peppercorn about 26 yards away. The nearest star to our sun, in that same shrunken model, would be another basketball more than 4,000 miles distant, somewhere across an ocean. The galaxy at that scale would still be unimaginably vast, and the observable universe would dwarf the galaxy by factors that break the comparison entirely. Now layer time onto that emptiness. Most of those basketball stars have not finished forming yet, in the grander sense. New ones keep igniting. Old ones keep dying and seeding the void with fresh ingredients. The galaxy you are picturing tonight will look different in 100 million years, and different again in 1 billion. And the cosmos will keep brewing planets long after our sun has cooled into a faint white ember. Some thinkers find this comforting. If the universe is mostly future, then perhaps life is mostly future too, and we are simply the early chapter of something enormous. Others find it unsettling. If the conditions for civilizations have only just become favorable, the silence around us may be exactly what we should expect, because almost no one has had the chance to arrive yet. Both views fit the same evidence. Neither can be ruled out tonight. So hold this gently as you rest. A quarter second of awareness on a peppercorn near the start of a road that runs for trillions of years. Whether we are early or alone, or simply too small to notice the others, the scale itself is the first part of the mystery. Picture yourself drifting high above the earth on a warm summer night, far from any city, far from any glow. The sky stretches in every direction, deep and dark, scattered with thousands of small lights. Each pinprick is a sun. Many of those suns have planets. Some of those planets, by every reasonable guess, should look a little like our own. And yet, when you listen, the sky says nothing. This is the quiet at the heart of one of the oldest cosmic puzzles. It is sometimes called the Fermi question. After a thoughtful pause taken during a casual lunch, many decades ago. The reasoning is simple enough to fit on a napkin. The galaxy is old. Stars formed billions of years before our sun. Even a slow civilization, creeping outward at a fraction of the speed of light, could cross the entire galaxy in a few tens of millions of years. That sounds long, but compared to the age of the galaxy, it is a blink. So the sky should be busy. It should hum with signals, glow with engineering, glitter with the warm waste heat of countless industries. Instead, when we point our best instruments at the dark, we hear a steady, patient silence. Imagine floating above the disk of the Milky Way and looking down. You would see a vast spiral of pale gold light, soft arms curling around a brighter core. Bands of dust would wind through it like dark rivers. Roughly 200 billion stars would shimmer in that slow wheel. Now imagine that somewhere in all of that, a single small blue world sits on a quiet outer arm, listening. It has been listening in a serious way for only a handful of decades. And so far, from all that golden sweep, it has heard nothing it can confidently call a message. There are gentler ways to phrase the puzzle, and harsher ways too. The gentle version simply notes that we have barely begun to look. Our radio surveys have scanned a small slice of the sky in a narrow set of frequencies for a short window of time. The galaxy is enormous, and our ears are still small. Under this view, the silence is not really silence. It is more like standing at the edge of an ocean at night and saying you have heard no ships when you have only listened for a minute with one ear on one beach. The harsher version says something different. It says that even granting our limits, we should already see signs that are hard to miss. Vast structures around stars, dimmings that follow strange patterns, the faint infrared glow of waste heat from civilizations that harness whole suns. The fact that we do not see these things anywhere we have looked might be telling us something real. It might be telling us that long-lived, sky-spanning civilizations are simply not common, or perhaps not present at all. Between these two views sits a wide field of theories, none of them settled. Some researchers wonder if civilizations tend to stay quiet on purpose, choosing to listen rather than shout. Some suggest that intelligence intelligent life rarely develops the kind of technology that leaks into space. Others propose that civilizations come and go in short bursts, and the chance of two of them overlapping in time is small. And then there is the possibility this whole episode is built around. Perhaps there are very few others yet. Perhaps we are early. Perhaps the great cosmic conversation has barely begun, and our small world is among the first voices clearing its throat. If you could see this question from outside time, it might look like a wide, dim plain stretching to every horizon. The plain is dotted with countless small fires that have not yet been lit. Here and there, a single flame flickers in the dark, alone, surrounded by miles of unlit ground. The flames cannot see each other yet. Maybe they never will. Maybe, given enough centuries, the plain will fill with light. From where we stand, on our own small flame, we cannot tell which picture is true. The honest answer is that the silence has many possible meanings, and we cannot yet choose between them. It might mean we are listening wrong. It might mean we are looking in the wrong places. It might mean the others are hiding, or sleeping, or long gone. It might mean they have not arrived yet, because the universe is still young, and the first ones must always begin in a quiet room. For tonight, the sky simply waits. Soft, dark, patient, scattered with suns that have not answered. The question of why drifts on, unresolved, above your slow and gentle breath. Beneath the simple silence of the night sky lies a deeper puzzle. If life and intelligence are common, then somewhere along the long road from a lifeless rock to a starfaring mind, something must usually go wrong. There must be a barrier, a wall, a quiet step that almost no species crosses. Researchers call this idea the Great Filter, and the question of where it sits, behind us or ahead of us, may be the most important question we have not yet answered. The Great Filter is not a place. It is more like a hidden gate along a path with many doors. To become a civilization that builds radios and probes and dreams of other stars, a planet must pass through many narrow steps. First, simple chemistry has to become self-copying. Then, those tiny copies must become true living cells. Those cells must learn to cooperate and form bigger bodies. Those those bodies must, in time, give rise to minds. Minds must give rise to language, then tools, then science, then long-lived societies that can reach beyond their own world. Any one of those gates could be the killer. The filter could be a single, nearly impossible step. Or it could be a long chain of merely hard ones. We do not know which. We do not even know how many gates there really are. We only know that the night sky looks empty, and that emptiness asks for an explanation. One quiet possibility is that the filter sits far behind us. Maybe the leap from non-living chemistry to the first living cell is the wall. On Earth, this happened only once, as far as we can tell. Every living thing we have ever studied shares the same deep code, the same basic machinery. If life had started over and over in warm pools and deep vents, we might expect to find strange cousins with different chemistry hiding somewhere. So far, we have not. That single shared beginning could mean the spark of life is rare beyond imagining. If so, we may have already passed the hardest test, and the road ahead, while long, is open. Another quiet possibility, gentler in some ways and darker in others, is that the filter sits ahead of us. Perhaps simple life is common, and even complex life arises often. But technological civilizations almost always stumble. They may exhaust their worlds. They may turn their tools against themselves. They may simply lose interest in the stars and fall silent. In this picture, the galaxy could be scattered with quiet ruins, with thin layers of strange chemistry buried in old soils, with no one left to send a signal. If the filter is ahead, then our young species stands before a wall that has stopped everyone else, and we cannot yet see its shape. There is a third possibility, softer and stranger. The filter might be spread out, with no single wall, only a long climb where many small risks slowly add up. In this view, no one step is impossible, but the full journey is so long and so fragile that very few finish it. We might be partway through, not knowing how many gates remain. A few thinkers have pointed out something gently unsettling about finding life elsewhere. If we discovered fossil microbes on Mars, or strange chemistry in the warm oceans beneath the icy crust of Europa, it would be one of the greatest moments in human history. And yet, it might also be quietly worrying. Because if life is easy, then the filter is more likely to lie ahead, not behind. Every empty world we find, every silent radio band, every barren shore on another moon may instead be a small comfort. Each absence could mean the hardest step is already behind us. Of course, none of this is settled. The great filter is a frame for thinking, not a measured fact. We have a sample of one planet, one biosphere, one species capable of asking these questions. From one example, you cannot draw firm conclusions about the whole universe. Some researchers wonder if the filter idea is even the right way to picture our situation. Maybe civilizations are simply spread so far apart in time and space that meeting one is almost impossible, even if they exist by the thousands. What we can say is this: somewhere along the path from dust to mind, the numbers thin. The sky tells us so in its calm and patient way. Whether we are near the end of a long climb or only at the beginning of a steeper one, we do not yet know. The gate may be far behind us, soft and old, or it may stand somewhere ahead, quiet in the dark, waiting. Before life can rise on any world, a long chain of quiet rhythms must turn in just the right way. A star must form in a calm patch of the galaxy. A planet must settle into a steady orbit. Heavy elements must already be woven into the dust that builds it. Water must arrive, stay, and remain liquid for billions of years. Each of these is a cycle on its own. Each one must align with the others, like nested gears in a slow and patient clock. This is the heart of an idea, sometimes called the rare earth hypothesis. It suggests that simple life may be common across the cosmos, but complex life, the kind that builds cities and asks questions, may need a strange chain of lucky accidents. Our planet sits in a narrow band where water can stay liquid. It orbits a stable star that does not flare too violently. It spins at a rate that gives us day and night without tearing the atmosphere away. And it carries a large moon that steadies its tilt over millions of years. That tilt matters more than it sounds. Without a steady axis, a planet can wobble wildly across long stretches of time. Its poles can swing toward the sun. Its seasons can grow chaotic and severe. Some researchers wonder whether life as complex as ours could survive such swings. Others think life is far tougher than we give it credit for, and that worlds with wild tilts might still grow rich biospheres in hidden corners. The cycle of plate tectonics is another quiet rhythm we rarely think about. Deep beneath our feet, the crust slides and folds in slow currents that take hundreds of millions of years. This motion recycles carbon between the rocks, the oceans, and the air. It keeps our climate from drifting too hot or too cold for too long. Without it, the thermostat of the planet might have failed long ago. We do not yet know how common this kind of geology is on other rocky worlds. It may be ordinary. It may be quite rare. Then there is Jupiter, the great giant that orbits far beyond us. Some scientists believe Jupiter has acted as a shield, sweeping up or flinging away countless comets that might have struck Earth. Others argue that Jupiter sometimes sends dangerous objects our way instead, and that its protective role is overstated. The truth likely sits somewhere between these views, shifting across the long ages of the solar system. What seems clear is that the arrangement of giant planets shapes the fate of smaller ones in ways we are only beginning to map. Our sun itself follows a slow cycle that matters for life. It brightens very gradually as it ages, growing about 10% more luminous every billion years. Earth has somehow kept its surface temperature in a livable range despite this rising heat. The cycles of carbon, water, and rock have buffered the changes. But this balance has limits. In the deep future, the oceans will boil, long before the sun itself ever swells into a red giant. The window for complex life on any single world is wide, but it is not endless. If you stack all these cycles together, the picture grows strange. A star of the right kind, a planet of the right size, at the right distance, with the right tilt, the right moon, the right neighbors, the right interior heat, and the right early bombardment of water-rich comets. Each requirement may be common on its own. Together, they may be uncommon. Or perhaps they are easier to meet than we think. and our own planet is simply one of many quiet successes scattered through the galaxy. This is where the question of being first becomes interesting again. If complex life truly does require many lucky accidents, then biospheres rich enough to grow minds might appear only on a small fraction of worlds. Spread that thin fraction across the cosmic ages, and intelligent observers might be very rare in any given era. We might not be alone in the long run. We might simply be early, born during a stretch when the gears have only recently begun to mesh in the right way. The competing view is gentler. Some researchers suspect that life finds many roads forward, that cycles we consider essential here might be replaced by other rhythms elsewhere, that the universe is patient and inventive, and that the path to mind is wider than our single example suggests. Both views remain open. Both rest on a sample size of one living world until we find another. The rhythms of Earth will keep their secret, turning quietly beneath us as we drift through another night, wondering how much of our story was needed and how much was simply fortunate. Around every star in the night sky, there is a soft ring of possibility. Astronomers call it the habitable zone. It is the band of distance from a star where a rocky world could hold liquid water on its surface. Not too close, where oceans would boil. Not too far, where they would freeze into stone. Earth sits inside the sun's habitable zone, and for a long time we thought such a place must be rare. Now we know better. The galaxy is full of them. Telescopes have found thousands of planets circling other stars. Many of them sit in that gentle ring of warmth. Some are larger than Earth, some smaller. Some orbit golden suns much like ours. Others swing around quiet red stars or pale orange ones. The math suggests there may be billions of rocky worlds in the right place across our galaxy alone. Billions of stages where life could, in theory, begin its slow performance. And yet, when we look, the lights stay off. No signals, no bright cities glittering on a night side, no clean lines of structure where there should be only stone and weather. The neighborhoods we can see appear empty. There are several ways to think about that quiet. One idea is that the habitable zone is a much narrower place than it first appears. A planet can sit in the right band of warmth and still fail in a dozen other ways. It might lack a magnetic field to shield its skies. It might tumble without a steady tilt, throwing its seasons into chaos. It might have no large moon to calm its spin. It might lose its water early, or never have enough to begin with. Warmth is only the doorway. What waits inside the room must be just right too. A competing view is gentler. Perhaps habitability is common, and life itself is common, but minds are rare. Microbes might be drifting in warm pools on 1,000 worlds within a few hundred light years of here. Slime might be coating stones beneath alien tides. None of that would reach us. A pond of bacteria sends no radio waves. A forest of moss builds no telescopes. The galaxy could be quietly alive and still appear silent to ears like ours. A third possibility leans the other way. Perhaps the habitable zones really are mostly empty, and we are seeing the truth of it. The neighborhoods around us may be full of stones and water and patient chemistry that simply never crossed the line into living. If that is so, then the loneliness we feel when we look up is not a trick of distance. It is the honest shape of our corner of the cosmos. Our nearest stellar neighbor is a small red star called Proxima Centauri, just over 4 light years away. A rocky planet orbits inside its warm band. We do not yet know if it holds water, or air, or any breath of life. It may be a sterile rock, scoured by flares from its restless sun. It may be a quiet ocean world hiding beneath cloud. The question sits there, 4 years away at the speed of light, and we cannot yet answer it. Beyond Proxima, the catalog grows quickly. There is the TRAPPIST system, with 7 small worlds packed close around a tiny star, several of them in the warm band. There is a long list of others, each found by the faint dimming of starlight as a planet crosses in front of its sun. Each one is a possible neighbor. Each one is, for now, a closed door. The strange part is the silence that wraps around all of it. If even a small fraction of these warm worlds gave rise to thinking creatures, the sky should be busy with their traces. Heat from their machines, light from their cities, stray signals leaking outward as ours do. Instead, we find nothing we can confirm. Either the worlds are empty, or the minds are quiet, or the distances are simply too wide for whispers to reach across. This is part of what makes the idea of being first so hard to dismiss. The neighborhoods are there. The seats are set out. The warm rings circle countless stars, and the room appears still. We do not know whether the stillness means no one ever arrived, or whether they arrived and left, or whether they are here, and we have not yet learned how to see them. For tonight, it is enough to picture those soft rings of warmth around so many distant suns. Empty or not, they wait in the dark, holding their possible oceans, their possible skies, their possible stories that may or may not have ever begun. Among all the stars that drift through the dark, one kind outlasts every other. Astronomers call them red dwarfs. They are small, cool, and dim, glowing with a soft ember light that you could never see with the naked eye from across the galaxy. A red dwarf is smaller than our sun, sometimes only a tenth as wide. It burns its fuel so slowly, so patiently, that it can keep shining for trillions of years. That number is hard to hold in the mind. Our sun will live for about 10 billion years. A red dwarf can live 100 times longer. Some of them will still be burning when every other kind of star has gone dark. They are the marathon runners of the cosmos, the quiet survivors, the last lights that will ever shine. This matters for our open question in a strange and beautiful way. If life needs time, then red dwarfs offer more time than anything else. They give planets a stable warmth for unimaginable stretches. A world circling a red dwarf today could still be circling it long after our sun has swollen, faded, and cooled into a cold ember. If patience is what life requires, these tiny stars are the most patient hearths in all of creation. Red dwarfs are also the most common stars in the galaxy. Some estimates suggest they make up around 3 out of every 4 stars in the Milky Way. They outnumber bright stars like our sun by a wide margin. The galaxy is not really a place of golden suns and blue giants. It is mostly a place of small red embers, glowing quietly in the dark. And yet, despite their numbers and their patience, we do not know if life can truly take hold around them. Here is where the mystery deepens. Red dwarfs are calm in old age, but in their youth, they can be wild. They flare. They throw out bursts of radiation that could strip the air from a nearby planet. A world close enough to feel their warmth might also be close enough to feel their fury. One idea is that this early violence sterilizes most red dwarf worlds before life can begin. The young star scorches the surface, blasts away the water, and leaves a bare rock turning in the dim glow. If that is true, then the longest-lived stars in the universe may also be the least friendly to life. The galaxy would be full of warm hearths with no guests beside them. Another idea pushes back gently. Some researchers wonder whether thick atmospheres or strong magnetic fields could shield a planet through the stormy early years. Once the star settles into its long, calm middle age, life would have all the time it could ever need. Trillions of years of soft red light falling on still oceans, while the rest of the cosmos slowly burns out around it. The question remains open. We have not seen the surface of any such world. We do not know which picture is closer to the truth. There is something else strange about red dwarf planets. To stay warm enough for liquid water, a world must orbit very close to its small, cool star, so close that the same side often faces the star forever. One hemisphere bakes in eternal day. The other freezes in eternal night. Between them lies a narrow ring of twilight, where the temperature might be just right. Some thinkers wonder if life could thrive in that ring, in a permanent dusk that never moves. Others suspect the contrast would be too extreme, the winds too violent, the chemistry too unstable. We simply do not know yet. Hold this picture in your mind for a moment. A small red star glowing like a coal in the dark. A planet close beside it, half in light, half in shadow, with a ribbon of soft pink twilight running between. The star will shine like this for 1 trillion years. Whatever happens on that world has time. Deep time. More time than the universe has yet lived through. And here we sit, in the brief golden age of a yellow sun that will not last nearly as long. If life is easier around red dwarfs, then we are early and we are odd. If life is harder there, then the long future of the cosmos may be emptier than we hoped. Both possibilities sit beside each other, waiting for evidence that may take generations to gather. For tonight, simply rest with the image, the patient red stars glowing softly across the dark, the quiet worlds turning beside them, waiting through ages we cannot picture, and the open question drifting between the embers of whether anything has ever woken up beneath that gentle, ancient light. Picture the universe not as something old and finished, but as something still being made. Most of the stars that will ever exist have not yet been born. Astronomers who study the slow rhythms of galaxies suggest that even now, the great age of starbirth is mostly behind us. Yet the stars still ahead, scattered across the trillions of years to come, may outnumber every star ever lit so far. We sit, in other words, near the early pages of a very long book. That single thought changes the shape of the question we are asking. If life needs stars, and stars are mostly a future event, then life too may be mostly a future event. The cosmos we look up at tonight is a young cosmos, dim with possibility, quiet with potential. Some thinkers find this gently humbling. Others find it strange and a little lonely. Both responses sit comfortably in the same calm darkness. The smallest details are often the most beautiful. Consider the slow drift of gas inside a spiral arm. Cold hydrogen clouds, thinner than the best vacuum we can make on Earth, gather over millions of years into denser knots. Inside those knots, dust grains the size of smoke particles begin to clump. Over more millions of years, the clumps collapse into protostars, hidden inside cocoons of warm dust that glow softly in the infrared. We almost never see this happening in real time. We see only frozen snapshots, like still photographs of a river. The chemistry of those clouds is delicate and small. Tiny ice crystals coat the dust grains, layered with water, ammonia, and simple carbon molecules. When a young star finally ignites, its light warms those crystals and sets off a slow chemistry that may seed the next generation of worlds. Each new star is, in some sense, a little richer than the last. Each one inherits the dust of the stars that came before. The universe is enriching itself, one quiet generation at a time. There is a measurement astronomers love for its softness. They call it the cosmic star formation rate, and it traces how many new suns light up across the visible universe each year. That rate peaked roughly 10 billion years ago, in an era when galaxies were smaller and bluer and crashed into each other often. Since then, the rate has been slowly falling. The fall is gentle, not a cliff. Like a tide pulling back, it leaves more and more of the universe in a calm, settled state. What this means for life is genuinely unsettled. One view holds that we are arriving fashionably late to the party. After the busiest era of starbirth, when most planets capable of hosting life have already formed. In this picture, the silence around us is the silence of a hall whose other guests have already settled into their seats. Another view sees us as arriving extremely early, before the long tail of small, patient red stars has even begun to mature their slow worlds. In that picture, the hall is still mostly empty, and the chairs are just being set out. Both pictures can sit inside the same data, which is part of why the question is so quietly alive. We do not yet know which interpretation the universe will turn out to favor. The numbers we have are blurred by distance and by the limits of our instruments. Each new telescope sharpens the count of distant galaxies a little. None of them so far settles the matter. The textures here are worth slowing down for. Imagine a small red dwarf, a faint ember of a star that will burn for trillions of years. Around it drifts a single rocky world, locked so that one side always faces the warmth. On the dim line between day and night, soft winds might move slowly across a still ocean. That world, if it exists, has barely begun its life. Its long story stretches forward so far that our own sun will have died and faded before its first chapter is half written. Multiply that scene by uncountable systems still to come. The future cosmos is not a dying place, not yet. It is a quiet nursery whose lights are still being switched on, one by one, in rooms we will never enter. Whether any of those future worlds will produce minds that look upward and wonder the way we do tonight is a question without an answer. We sit in the soft middle of a slow story. Behind us, the brightest era of starbirth is already a memory written into the light of distant galaxies. Ahead of us, a long, patient evening of small red suns is just beginning. Where life truly belongs in that timeline remains open, and that openness is part of the gentleness of the night. For most of human history, the question of when life could exist in the universe had no real shape. The sky was simply the sky. The stars were lights, fixed and eternal, and the idea that the cosmos itself had a beginning would have seemed strange to nearly every culture that ever looked up. People wondered about other worlds, of course. Greek thinkers like Epicurus imagined many Earths scattered through infinite space. But the question of whether life had a window in time, a particular age when it could and could not arise, was simply not askable. The universe was thought to be timeless. The first crack in that idea came slowly, through the patient work of geologists in the 18th and 19th centuries. They studied layers of rock and realized the Earth itself was old. Not thousands of years old, as many had believed, but millions, and then billions. Each new method of measurement pushed the number further back. By the early 20th century, radioactive dating gave Earth an age of around 4.5 billion years. That alone was a quiet revolution. If the Earth had a birthday, then perhaps the sky did too. The real shift came in the 1920s, when astronomers began measuring the light of distant galaxies and noticed something unexpected. The galaxies were moving away from us, and the farther they were, the faster they fled. This pattern hinted that the universe was expanding. And if you ran the expansion backward in your mind, everything seemed to collapse toward a single hot beginning. The idea was strange and not universally welcomed. Some astronomers preferred a steady, eternal cosmos that never changed on the largest scale. The debate lasted for decades. Then, in the 1960s, two radio engineers picked up a faint, even hiss in their antenna. No matter where they pointed it, the hiss was there. They cleaned the dish. They chased away pigeons that had nested inside it. the hiss remained. What they had stumbled onto was the cosmic microwave background, the faint afterglow of the early universe itself, cooled and stretched by billions of years of expansion. With that quiet hum, the idea of a beginning became hard to deny. The universe had an age, and if it had an age, then so did the possibility of life. The next question followed naturally. When could life have first appeared? Astronomers began studying the chemical makeup of old stars and noticed something curious. The oldest stars contained almost no heavy elements. They were nearly pure hydrogen and helium, the simple gases left behind by the early cosmos. The carbon, oxygen, nitrogen, iron, and silicon that life and planets need were largely missing. Those elements had to be cooked inside stars over many generations, then scattered into space when those stars died. This was the work of nuclear astrophysicists in the mid-20th century, who slowly mapped out how elements form inside stellar furnaces. They showed that each generation of stars enriches the next, building up the cosmic pantry one explosion at a time. From this, a rough timeline emerged. For the first billion years or so, the universe simply did not have enough of the right ingredients in the right places to make rocky planets like ours. The window for complex chemistry opened only later, as galaxies matured and seeded themselves with the dust of dead suns. How wide that window remains an open question. Some researchers argue that conditions became suitable for life relatively early, perhaps within 2 or 3 billion years after the beginning. Others suggest the window opened more gradually, and that planets like Earth only became common much later. A few have proposed that we sit close to the earliest moment when a technological mind could plausibly emerge anywhere in the cosmos. Others believe many such windows opened long before ours, and that we are simply latecomers who missed the company. The data does not yet settle the matter. What is striking is how recent all of this knowledge is. The age of the Earth, the expansion of the universe, the origin of the elements, the cosmic background, the timing of habitable worlds. Every piece of this picture was assembled within the last 2 centuries, and most of it within the last 100 years. for nearly all of human existence, no one could even frame the question of whether we might be early. The instruments did not exist. The concepts did not exist. We are among the first generations of our own species to be able to ask, in a serious way, whether we might be among the first minds in the universe. And the asking itself is still very new, still finding its footing, still gathering the patient evidence that might one day, perhaps, begin to answer it. For more than 60 years, we have been listening. Patient antennas, some shaped like vast white dishes, others like long fields of wire and metal, have been turned toward the sky, sweeping across frequencies, gathering the faint hiss of the cosmos. The hope has always been the same. Somewhere in that hiss, hidden between the natural crackle of stars and the steady hum of galaxies, there might be a pattern, a repeating tone, a signal too clean to be random, a whisper from someone else who learned how to build radios. So far, the sky has stayed quiet. That quiet is one of the strangest facts in modern science, and it is stranger than most people realize. The galaxy is enormous, with hundreds of billions of stars, and we have only sampled a tiny sliver of it. Some estimates suggest we have searched a portion of the sky equivalent to dipping a small drinking glass into the ocean and finding it empty of fish. By that measure, the silence means almost nothing. We have barely begun. And yet, even that small sample carries a strange weight, because radio waves travel at the speed of light, and the galaxy is old. Any civilization that took up broadcasting even 1,000,000 years ago could have filled the local neighborhood with signals many times over. 1,000,000 years is a blink in cosmic time. If the galaxy were full of chatty neighbors, you might expect the sky to be glowing in radio, the way a city glows at night when you fly above it. Instead, the sky looks dark in those frequencies. No clear beacons, no structured pulses, no friendly hello. There have been moments that made hearts race. In 1977, a telescope in Ohio picked up a strong, brief burst from the direction of the constellation Sagittarius. The astronomer who noticed it wrote the word "wow" in the margin of the printout, and the name stuck. The signal lasted about 72 seconds and was never heard again. Decades later, researchers are still arguing about what caused it. One idea points to a passing cloud of hydrogen gas around a comet. Another suggests some natural event we do not yet understand. A few still wonder if it was, just possibly, something else. The honest answer is that nobody knows. There have been other puzzles too. Fast radio bursts, intense flashes lasting only thousandths of a second, arrive from distant galaxies in numbers that surprised everyone. For a while, some researchers wondered if they could be artificial. The current leading guess points to highly magnetized dead stars called magnetars, but the picture is still being filled in. The mystery shrinks, then grows again, then shrinks. This is how science usually moves. What makes the radio silence so interesting in the context of our question is that it cuts in two directions at once. If we are the first civilization, the silence makes perfect sense. There is no one out there yet, so of course, no one is broadcasting. The universe is simply too young, the heavy elements too freshly cooked, the stable planets too recently settled. We arrived early, and the room is still empty. But there is another reading, equally valid, that nudges the puzzle sideways. Maybe civilizations are common, but radio is a brief technology. Our own species has been broadcasting strongly for only about 100 years. And already, we are shifting to tighter beams, fiber cables, and quieter signals that leak less into space. If every civilization passes through a loud radio phase that lasts only a few centuries, then catching one in the act would be like trying to photograph a single firefly across a darkened continent. The sky could be full of minds, and we might still hear nothing. A third possibility sits quietly beside the others. Perhaps civilizations exist, but choose silence. Perhaps they listen the way we listen, cautious and unsure. None of them willing to be the first to call out. This is sometimes called the dark forest idea, and it remains speculation, not science. There is no evidence for it. There is no evidence against it either. So the antennas keep turning. New surveys with faster computers and wider frequency ranges sweep across the sky each year. The search is growing, slowly, patiently, like someone learning to read a book written in a language they have have only just begun to recognize. For now, the silence holds. It might mean we are alone. It might mean we are early. It might mean we are simply not yet listening in the right way. The whispers, if they exist, have not yet reached us, and the quiet sky above our beds keeps its secret a little longer. Long ago, a physicist imagined a strange and quiet possibility. He wondered what an old civilization might do if it lived long enough to need vast amounts of energy. The answer he reached was simple in shape and almost dreamlike in scale. Such a civilization might build a great shell of mirrors and panels around its own star. Not a solid sphere, but a soft cloud of countless platforms, drinking in the light that would otherwise escape into the dark. The idea came to be called a Dyson sphere, after the man who first wrote it down in a short paper in 1960. It was never meant as a prediction. It was a thought experiment, a way of asking what the signs of advanced life might look like from far away. If a star were wrapped in such a swarm, its visible light would dim, but the heat from all those panels would still glow softly in the infrared. The long, warm wavelengths our eyes cannot see. So the search became a kind of listening, only with light instead of sound. Astronomers began to scan the sky for stars that seemed strangely warm in the infrared and strangely quiet in the visible. For decades, the search has turned up nothing certain. A few candidates have flickered into the headlines, then faded back into ordinary explanations. Dust clouds, swarms of comets, stages of stellar aging we did not fully understand. Each time, the natural answer fit better than the artificial one. The sky, so far, looks empty of these slow, glowing constructions. There are several ways to read that emptiness. One reading is that no one is out there building such things. Another reading is that they are out there, but they build differently than we imagined. Perhaps a truly old civilization would not want to wrap its star at all. Perhaps it would find ways to live on much less energy, or to live in cold, hidden places where their work would never shine. The Dyson dream may simply be a human dream, dressed up in cosmic clothing. There is a deeper connection here, though, and it ties the sky to everything else in our story. A civilization that builds a Dyson swarm would not act alone in the universe. Its waste heat would warm the dust around it. Its gathered light would no longer reach distant galaxies. Its mining of asteroids, its reshaping of moons, its slow spreading from star to star, all of these would leave fingerprints. The sun touches the ocean through warmth and tides. Volcanoes touch the climate through ash and gas. A long-lived civilization would touch its galaxy in the same way, only more deliberately and across far greater spans of time. So when we look out and see galaxies that seem to spin and shine in ordinary ways, we are also seeing something else. We are seeing galaxies that, as far as we can tell, no one has rearranged. No dimmed cores. No strange infrared halos sweeping across entire spiral arms. No bands of starlight gone missing in patterns that natural processes cannot explain. The harmony we observe is the harmony of physics alone, with no orchestra of minds tuning it from within. That could mean many things. One possibility is that we truly are early, and the great builders simply have not arisen yet. Another is that civilizations rise often, but rarely choose to expand on such scales. Perhaps wisdom, when it comes, prefers smallness. Perhaps the urge to wrap a star fades once a species understands what it would cost. A third possibility is sadder and quieter. Civilizations may rise and fall before they ever reach the stage of stellar engineering, leaving their home worlds gently, without a trace in the wider sky. Each of these answers connects back to the same open question. If we are the first, then the empty infrared sky is exactly what we should expect, because the symphony has not yet begun. If we are not the first, then the silence is telling us something important about how minds and stars and time fit together. Either way, the search continues. New telescopes look for warm shadows around quiet stars. Surveys map the infrared sky in finer and finer detail. And so far, the great cosmic instruments seem to be playing only the music of gravity, fusion, and dust. It is a strange thing to listen for, a warmth that should not be there, a dimming with no natural cause, a pattern of stars too tidy to be an accident. Tonight, that listening goes on, patiently across observatories scattered around our small blue world. And the sky, for now, keeps its long and gentle silence, neither confirming the dream nor putting it finally to rest. There is an old idea that life does not need to begin on a planet at all. Maybe it drifts in. Maybe the first seeds of biology travel through space, tucked inside grains of dust, or buried in the cold hearts of comets. The idea has a name. It is called Panspermia, and it asks whether life on Earth might have arrived here rather than starting here. If that is true, then the question of who is first becomes much stranger, because the seed and the soil might be very far apart in time and space. The idea is older than you might think. Some thinkers in ancient Greece wondered whether the seeds of living things were spread throughout the cosmos, waiting for a warm world to land on. In the past century, the question came back in a quieter, more careful form. Researchers began to ask whether microbes could survive the long, cold drift between worlds, whether they could ride a meteorite, whether they could sleep inside a rock for 1,000,000 years and wake up when the conditions were right. Some experiments hint that certain tiny organisms can endure remarkable things. They can survive deep cold, harsh radiation, and the vacuum of space for surprising lengths of time. Whether they could survive the full crossing from one star system to another is a much harder question. That kind of trip might take many millions of years, and the radiation alone would slowly erase most living chemistry. So panspermia between stars remains a quiet possibility, not a proven path. Panspermia within a single solar system, from one planet to its neighbor, seems a little more plausible, though still unproven. If panspermia is real, the story of being first changes shape. The Earth would not be the cradle. It would be the nursery. The actual birth of life might have happened on some older, warmer world long before our planet cooled. That world might be gone now, crushed into a star, or scattered across the void. Its descendants might be everywhere, slowly drifting between systems, finding new homes one quiet landing at a time. In that picture, we would not be the first life. We would be a late echo of something much older. But there is a competing view that pulls in the other direction. Many researchers think life most likely began on Earth, built from the chemistry of our own oceans and our own warm pools. The ingredients were here. The energy was here. The time was here. There is no clear need to bring life in from outside, and adding a long interstellar trip only adds a problem rather than solving one. In this view, the origin of life is a local event, and Panspermia is a beautiful idea that the evidence does not yet require. Still, the seed's question lingers in another way. If Panspermia happens at all, even rarely, then the cosmos should carry a slow, gentle scattering of biological material. Over billions of years, that scattering should add up. Worlds that pass through ancient debris clouds might catch a stray spore. Young planets forming near the ruins of older systems might find their first chemistry already prepared. We do not see clear signs of this. The planets we have studied so far show no obvious imported life. The silence here is as loud as the silence in the radio sky. There is something quietly humbling in this. If seeds were sent by chance or by some long-vanished mind, they have not visibly taken root in the places we can see. If no seeds were ever sent, then life must begin fresh on each world that grows it. And that beginning may be far more difficult than we know. Either way, we sit in a strange position. We are a living world surrounded by what looks like sterile neighbors, holding a question we cannot yet answer. The slow changes here happen on timescales that dwarf our histories. A comet that left one star system might take tens of millions of years to drift past another. A spore frozen in a grain of dust might wait 100 million years before touching warm water again. The cosmos is patient in a way we struggle to feel. Whatever is moving between the stars, it is moving in a kind of geological hush, far slower than any story we have ever told. So the Panspermia question stays open, like so many in this episode. Maybe the seeds came, and we are their distant flowering. Maybe the seeds never came, and life rose here on its own. Maybe the seeds are still drifting, and we have never crossed their path. We do not yet know which of these is true, and the night sky, quiet as ever, does not seem to be in any hurry to tell us. Look up on a clear night, and the moon hangs there like a soft silver lamp. Its light is borrowed, of course, bounced from the sun across 250,000 miles of empty space. That gentle glow has shaped tides, calendars, poems, and perhaps something far stranger. The moon may be one of the quiet reasons we are here at all, looking up and wondering whether anyone else ever has. Our moon is unusual. It is enormous compared to the planet it circles, about 1/4 of Earth's diameter, far larger in proportion than the small captured rocks that orbit Mars, or the distant ice moons of the outer worlds. The leading idea is that a Mars-sized body struck the young Earth, and the debris settled into a ring that gathered itself into our pale companion. That collision, if it happened as we suspect, was a single event of staggering luck. Other rocky planets do not seem to have anything quite like it. The light the moon reflects does more than decorate the sky. Its gravity gently steadies Earth's tilt, the angle at which our planet leans as it orbits the sun. Without that steadying, the tilt might wobble across wide ranges over millions of years, sending the climate lurching from one extreme to another. With a stable tilt, seasons stay roughly the same across long ages, and life has a quieter stage on which to slowly evolve. One possibility is that without the moon, complex life would have had a much harder road. Some researchers wonder if it would have been possible at all. Then there is Jupiter, the giant lantern of the outer solar system. On dark nights, it shines as a steady, creamy point of light, brighter than any star. Through a small telescope, you can see its banded clouds in soft browns and tans, and 4 bright moons strung beside it like beads. Jupiter holds more mass than all the other planets combined. Its gravity reaches far across the solar system, tugging on everything that passes. The old story says Jupiter is our shield. Its gravity, the thinking goes, sweeps away comets and asteroids that might otherwise rain down on Earth. In this telling, the giant planet acts like a patient guardian, taking hits so that we do not have to. The famous breakup of a comet into Jupiter's clouds, leaving dark bruises in its banded atmosphere, seemed to confirm the picture. Some simulations suggest that without Jupiter, Earth would face many more impacts than it does. Other studies disagree. Some models suggest Jupiter is just as likely to fling distant icy bodies inward as to deflect them outward. In that view, Jupiter is not purely a shield, but something more complicated, a stirrer of the deep solar system whose net effect is harder to judge. The question of how much we owe to that gleaming giant remains open. We cannot rerun the experiment with a different solar system to see what would have changed. Even the placement of Jupiter matters. In many of the planetary systems we have found around other stars, giant worlds sit close in, whipping around their suns in days. Such hot giants often plow through the inner regions during their formation, scattering or destroying any small rocky worlds along the way. Our Jupiter, by contrast, settled at a comfortable distance, far enough out that the inner solar system was left mostly intact. One idea is that this orderly arrangement is rare. Another is that we simply have not yet found enough quiet systems like ours to know. So picture the scene from far away. A small blue and white world lit by a steady yellow star. A large pale moon circling close, holding the planets tilt firm. A banded giant farther out, glowing in reflected sunlight, shaping the orbits of countless smaller bodies. Each light in this arrangement plays a role we do not fully understand. Remove any of them, and the story of Earth might have ended in a different chapter, or not begun at all. If these lucky details truly are rare, then the silence we hear when we listen to the sky begins to feel less like absence and more like patience. Perhaps few worlds get a moon like ours. Perhaps few get a Jupiter in the right place. Perhaps the long, slow climb toward minds that can wonder needs exactly this kind of quiet stage. And stages like this are uncommon. Or perhaps we are overweighting our own arrangement, mistaking the conditions we know for the only ones that work. The moon will rise again tonight, as it always has. Its borrowed light will fall across rooftops and oceans, and Jupiter, when in season, will hang nearby like a steady candle. Whether they are reasons we are first, or simply lucky details of one story among many, remains an open question. If you could press an ear to the long story of life on Earth, what would you hear? Not the sounds of one moment, but the slow music of 4 billion years pressed together. For most of that span, you would hear almost nothing. A faint rustle of warm water, the low hum of chemistry stirring in shallow seas, the patient hiss of microbes too small to see, doing the quiet work of staying alive. This near silence lasted for an astonishingly long time. Life appeared on Earth fairly early, perhaps within the first billion years after the planet cooled. And then, for nearly 3 billion years after that, it stayed simple. Single cells, mats of microbes spreading across tidal flats. The world was alive, but it was muted. No songs, no footsteps, no thoughts, just the slow breathing of an ocean full of strangers too small to know each other. Why did the climb take so long? That is one of biology's deepest open questions, and it sits very close to the question of whether we might be the first. Some researchers suspect that the jump from simple cells to complex ones was the hardest single step in the entire history of life on Earth. Complex cells, the kind that built every animal and plant, may have arisen only once, through a strange merger between two ancient microbes. If that merger was a fluke, the silence of those first 3 billion years may not be a delay. It may be a clue. Other researchers wonder if the slowness had less to do with luck and more to do with the air. Oxygen built up gradually in long pulses as photosynthesis spread and chemistry shifted in the oceans. Without enough oxygen, large active bodies could not power themselves. The sound of breathing, in any real sense, had to wait for the sky to change. Which view is closer to the truth remains unsettled. Once complex life did arrive, the volume slowly rose. The first creatures with hard shells clicked softly against each other in shallow seas. Fish carved currents through the water. Insects took to the air with the dry whir of new wings. Forests grew and creaked. Storms rolled across continents that had never heard thunder bend around a tree. The planet, after billions of quiet years, was finally noisy. Even then, the climb to minds capable of asking cosmic questions took hundreds of millions of years more. Brains grew slowly, in small increments, across countless lineages that rose and faded. The deep song of whales, the calls of birds at dawn, the rustle of small mammals moving through leaves. These sounds drifted across the world long before any creature could wonder where the stars came from. Curiosity, as far as we know, is a very recent sound. Our own voices in the long arc are almost brand new. Spoken language may be only a few 100,000 years old. Writing is perhaps 5,000. Radio, less than 150. If you compressed the history of Earth into a single day, the entire age of human technology would fit into the final fraction of a second before midnight. The sound of a civilization broadcasting into space is, on planetary timescales, barely a whisper at the very edge of the day. This is part of why the question of being first is so hard to set aside. If the climb from microbes to minds really does take billions of years, and if it depends on rare events like that ancient cell merger, or the slow oxygenation of an ocean, then the universe may simply not be old enough yet for many such climbs to have finished. Stars older than the sun have existed for a long time, yes, but the planets around them needed time of their own. Their oceans needed time. Their cells needed time. Their forests, if they have any, needed time. There is a competing view, of course. Some researchers suspect the climb may go faster on other worlds, where the chemistry is kinder, or where the early jump to complex cells happens more easily. We have only one example of life to study, and one example is a poor guide to the average. The honest answer is that we do not know how typical Earth's pace really is. So when you listen tonight to the quiet around you, the soft sounds of a room, the faint movement of air, your own slow breathing, you are hearing the late chapter of a very long piece of music. Most of that music had no listeners. It played in empty seas, under skies no eye had yet evolved to see. Whether other worlds are playing their own long pieces right now, with no one listening yet, remains one of the gentlest open questions we have. There is a strange kind of math hidden inside the question of who came first. It does not need fancy symbols or long equations. It only needs a few simple numbers, gently arranged answers begin to whisper back. The universe gives us its rules in clean and quiet shapes. We just have to listen for them. Start with the age of the universe. About 13.8 billion years have passed since the first light. Earth is about 4.5 billion years old, roughly a third of that span. Complex life on Earth is younger still. Only a few 100 million years in any rich form. And technology, the kind that sends signals into the dark, is barely a century old. Set those numbers side by side, and a strange ratio appears. The window in which we have been a technological species is 1 part in 100 million of cosmic time. That ratio is the first piece of the puzzle. If civilizations are common, we would expect to find ourselves among the late arrivals, not the early ones. There has been so much time before us, yet the sky is quiet. So perhaps the ratio is telling us something. Perhaps we are early, not late, and the silence above is simply the silence of an empty room before the guests arrive. There is a model that takes this idea and shapes it into numbers. Some researchers call it the Grabby Aliens model. It imagines that loud, expanding civilizations are rare, and that once they appear, they spread quickly across the sky. The math then asks a simple question. Given that we exist, and given that we do not see any such civilizations yet, when in cosmic history should we expect to find ourselves? The answer the model returns is gentle and surprising. We should expect to be early, not impossibly early, but early enough that the sky still looks empty. Other researchers push back on these numbers. They point out that the model rests on guesses we cannot test. How fast does a civilization spread? How visible is it from far away? How often does life cross the long bridge from microbes to minds? Change any of these guesses, and the answer slides in a new direction. The math is elegant, but it leans on assumptions we have no way to check. The question remains open. Still, there is something lovely about the shape of these arguments. They use only the simplest tools. A few ages, a few ratios, a few honest unknowns. From these, thoughtful minds try to estimate where we sit in the great river of time. The numbers do not prove anything. They only sketch the edges of what is possible. Consider another piece of the math. smallest red dwarf stars, the most common stars in the galaxy, can burn steadily for trillions of years. Our sun will only shine in its current calm form for about 10 billion years total, and it is already roughly halfway through. Compared to the lifetime of a red dwarf, our sun is a brief candle. If life favors long, stable suns, then most of the universe's habitable history lies far ahead of us, around stars that have barely begun their slow burn. By that measure, we are not just early, we are near the dawn, and yet the math cuts both ways. Red dwarfs flare. Their habitable zones are tight and strange. We do not know if life can settle comfortably around them. So the long future they promise may not be the future biology actually uses. The numbers point toward an early arrival, but they do not insist on it. There is one more ratio worth holding in mind. The observable universe contains somewhere around 2 trillion galaxies, each with billions of stars. Even if technological life is vanishingly rare, the sheer count seems to demand company. But rarity is a slippery word. If the chance of a civilization arising around any given star is small enough, then 2 trillion galaxies might still produce only a handful of minds, scattered so far apart in space and time that they never meet. The math allows for a crowded universe and a lonely one in equal measure. This is the burden the numbers place on us. They do not solve the mystery. They only show how thin the thread is on which our company depends. We could be the first. We could be one of many. The same equations describe both worlds, and we cannot yet tell which one we live in. So tonight, the numbers rest gently in the background, neither answering nor pressing, simply holding the question open beneath the quiet sky. If we are truly the first, then any message we send into the dark is a kind of bottle thrown into a vast and quiet ocean. We have already begun to throw a few. Small craft now drift past the outer planets, carrying engraved plates and golden records. They were built in the 1970s, and they move at speeds that seem fast to us, yet are slow against the gulf between stars. None of them will reach another sun for tens of thousands of years. And even then, they will pass through systems mostly empty, with little chance of being noticed. think of how thin the chain of conditions is that allowed those probes to exist at all. The metals in their bodies were forged inside dying stars, scattered across the galaxy long before the sun even formed. The silicon in their circuits, the gold on their records, the plastics in their wiring. Every atom traveled a long road through supernovae and slow drifting clouds before settling into the crust of one small planet. If the early galaxy had stirred its ingredients a little differently, the rocks beneath our feet might have held too little iron, too little copper, too little of anything to build a radio. Earth itself sits inside a balance so narrow it almost seems painted by hand. Our distance from the sun keeps water liquid across most of the surface. A little closer, and the oceans would boil away into a thick, scalding sky. A little farther, and they would freeze solid down to the seabed. The atmosphere above us is only a few tens of miles thick, a thin blue shell wrapped around a stone ball. From space, it looks like a soft glow at the edge of the horizon, almost too delicate to hold a sky at all. Yet it holds the air we breathe, blocks most of the harsher light from the sun, and keeps the surface warm enough for rain. Below that air, a molten core spins and stirs, generating a magnetic field that reaches far out into space. That invisible field deflects the steady stream of charged particles flowing from the sun. Without it, those particles would slowly strip the upper atmosphere away, one molecule at a time. Mars likely lost much of its air in just that way long ago, after its inner dynamo went quiet. Our own dynamo still turns, for reasons we only partly understand, and the air remains. Even the slow rotation of the planet matters. A day that lasted a year would scorch one face and freeze the other. A spin too fast would whip the winds into something violent and constant. The tilt of the axis gives us gentle seasons rather than wild swings. The large moon overhead steadies that tilt, keeping it from wobbling across long stretches of time. Take away any one of these props, and the stage we stand on becomes harder to imagine. If being a planet that hosts life is already this delicate, then being a planet that builds beacons is more delicate still. A civilization needs not only a steady world, but but steady centuries on top of that world. Centuries of curiosity, of patient learning, of resources not yet exhausted. A single bad turn in climate, a single careless century, and the chain of knowledge can fray. Some thinkers wonder whether this fragility is itself part of the answer to the silence. Perhaps many worlds reach the edge of sending messages, then fall back before the first signal leaves. Others wonder the opposite, that worlds reach this edge so rarely that most never arrive at all, and we are simply among the very first to manage it. Both views leave the question open. We cannot tell from inside our own story whether the path we walked was common or strange. We only know it was narrow. The probes drifting out past the heliopause, the faint radio chatter leaking from our cities, the carefully aimed messages sent toward a few nearby stars. All of these are small acts of hope, sent from a balance we did not design and barely understand. If someone, somewhere, ever finds one of those bottles, they will hold in their hands the proof that a thin atmosphere on a small blue world once allowed minds to dream of company. And if no one ever finds them, the bottles will keep drifting all the same, quiet metal seeds carrying the memory of a place where everything happened to line up. Whether that lining up was the first of many or one of a precious few is a question we cannot yet answer. For now, the messages float outward and the balance holds, and the sky above us stays mostly silent. Step back for a moment and picture the universe not as it is now, but as it will be. Not in a year or 1,000 years, but in spans of time so long they stretch the mind. The cosmos is only about 13.8 billion years old. That sounds vast. It is vast, but compared to what is still to come, it is barely the first breath of a very long life. Stars will keep forming for trillions of years. Small red dwarf stars, the most common kind in the galaxy, can burn quietly for 10 trillion years or more. That is nearly 1,000 times the current age of the universe. If you imagine the lifespan of the cosmos as a single long evening, we are not yet at sunset. We are barely past the first soft minutes of dawn. This is one of the gentle puzzles at the heart of our question. If the universe is so young, and most of its star-burning life still lies ahead, then most of the civilizations that will ever exist may not have been born yet. Some researchers find this a powerful clue. Others are not so sure. The math depends on assumptions we cannot test. One open question is simply this: when in cosmic time is life most likely to appear? Some studies suggest the peak window for habitable worlds lies far in the future, around long-lived red dwarf stars. Other studies suggest the present era is roughly typical, and that life-bearing planets could be scattered evenly across many billions of years. The two views give very different answers about how alone we are tonight. There are deeper unknowns nested inside that one. We do not know how often life begins on a suitable world. We do not know how often simple life crosses the long bridge to complex life. We do not know how often complex life develops minds that build tools, ask questions, send signals. Each of these steps could be common, or each could be vanishingly rare. The numbers we plug in are mostly guesses dressed in careful language. Another unsolved piece is the lifespan of a technological species itself. A civilization that lasts 1,000,000 years would leave a very different mark on the sky than one that lasts 1,000. We have no examples to draw from except our own short story, and our own story is still being written. How long minds like ours tend to endure is one of the largest blank spaces on the cosmic map. There is also the question of what a very old civilization would even look like. Would it spread outward in slow waves, lighting up galaxies in patterns we might one day notice? Would it pull inward, growing quieter and more efficient, leaving almost no trace at all? Both ideas have thoughtful supporters. Both remain unproven. The sky, so far, does not clearly show either pattern. And there is the strangeness of our position in time. If life becomes more likely as the universe ages, then we are early. If life was more likely in the past, when star formation was faster, then we are late. If the odds are roughly flat across cosmic history, then we are simply somewhere along the line. Each of these stories fits the evidence we have, because the evidence we have is still very thin. The honest answer, the one researchers return to again and again, is that we are working with a sample size of one planet with life, one species that wonders about the stars. From a single example, we cannot draw firm conclusions about the whole. Every careful estimate carries an invisible label that reads, more or less. We do not yet know. There is something quietly hopeful in that uncertainty. It means the question is still alive. It means the next telescope, the next mission, the next strange signal in the data could shift the picture in ways we cannot predict. The deep future of the cosmos is not yet written, and neither is our understanding of it. For tonight, let the unsolved parts rest as they are. The universe is young. The stars will keep shining for an almost unimaginable stretch of time. Somewhere in that long unfolding, the answer to whether we are first or early or simply rare will become clearer. Or perhaps it will not. Perhaps the question will deepen instead, the way good questions often do. Imagine the slow dawn of a cosmos that has barely begun. Imagine the trillions of quiet years still ahead, full of worlds not yet formed, minds not yet born, questions not yet asked. We sit at the very beginning of that long morning, holding a small lantern of curiosity, looking out at a sky that has not finished telling its story. The silence we listen into each night carries weight. We point our antennas at quiet stars, sweep across patches of sky, and hear mostly the soft hum of the universe itself. No clear signal, no greeting, no proof of anyone out there at all. And so, we wonder what that silence is telling us, if it is telling us anything yet. One reading of the silence is gentle. Maybe we have simply not listened long enough, or in the right way. The galaxy is vast, and our search has covered only a thin slice of frequencies for only a few decades. A whisper could be passing through this room right now, tuned to a band we have never thought to check. In this view, the quiet is not an answer. It is the sound of a search that has barely begun. Another reading is stranger. Some researchers wonder if the silence means we are early, if technological minds become common later in the life of the universe. Then the sky around us would naturally look empty, because the others have not arrived yet. The galaxy in this picture is not abandoned. It is unfinished. the stage is being set, and we are the first to walk out under the lights. A third reading is harder to sit with. Perhaps civilizations do appear, but they do not last. They reach a certain step, stumble, and fall quiet again. In that case, the silence is not a beginning or a delay. It is a pattern. Each reading remains a theory. None can be proven from where we stand tonight. Now imagine pressing the clock forward. 1,000,000 years from now, our species, if it survives, will be almost unrecognizable to us. Cities may rise on other worlds. The night sky, as seen from Earth, will have shifted because the stars are always drifting, slowly rearranging the old patterns we once named. The constellations our ancestors drew will have melted into new shapes. Whoever looks up will see a different sky. Push the clock further. In 1,000,000,000 years, the sun will be hotter and brighter, and Earth's oceans will likely be in trouble. The continents will have ground into new arrangements, perhaps fused into a single great landmass before splitting again. Life, if it remains, will have moved, adapted, or thinned. Our descendants, if there are any, may live on moons we now consider frozen, or inside structures we cannot yet imagine. Whether they still wonder about other civilizations is an open question. Push further still. The Andromeda Galaxy is drifting toward our own. In roughly 4 billion years, the two great spirals will begin to merge, weaving their stars into a slow, glowing dance that will take hundreds of millions of years to settle. No stars will collide. Space between them is too wide. But the night sky of any world still spinning then will be filled with strange new light as two galaxies become one. By the time that merger finishes, the sun will be near the end of its long life. It will swell into a red giant, swallowing the inner planets, and then shed its outer layers in a quiet, glowing shell. What remains will be a small, dense ember, cooling slowly into the dark. Earth, if it still exists in some form, will not be the world we know. The universe will keep going. New stars will form from the gas of dying ones, often smaller and longer lived. Red dwarfs will burn for trillions of years, far outlasting the era we live in now. If the question of company is still being asked then, the answer may be very different. Perhaps minds will be common across the cooling sky. Perhaps the silence we hear tonight is only the silence of an early morning before the others wake up. There is also the possibility we cannot quite bring ourselves to picture that the silence is permanent, that in all the long unfolding of the cosmos, only a few flickers of awareness ever appear, scattered like distant candles across unimaginable distances, never close enough in space or time to find one another. In that picture, being first is not a stage. It is simply what it is to be a mind in a universe this large. No one knows which of these futures we are inside. The data does not yet say. What we can say is that the universe is always becoming something else. The stars we see now are not the stars our descendants will see. The questions we ask now may not be the questions they ask. The silence around us tonight is a kind of patience. It waits for us to listen longer, to think more carefully, and to keep wondering at the edge of what we cannot yet hear. Step back now, as far back as the mind can travel. Picture the whole of the universe, all at once, as a single quiet shape. It began nearly 14 billion years ago, in a moment we still do not fully understand. From that beginning, hydrogen and helium spread outward in a soft, even mist. There were no planets then, no stars, no watchers of any kind. The first stars lit themselves slowly, gathering in the cold dark, burning fast and dying young. Inside those stars, the simplest atoms pressed together and became something heavier. Carbon, oxygen, iron. When those early stars collapsed and exploded, they scattered their hearts across the dark. Each supernova was a forge, and every forge sent its gifts, drifting into the next generation of clouds. Those clouds collapsed into new stars. New stars made new elements. And so the cycle turned again and again for billions of years, slowly seeding the cosmos with the building blocks of worlds. Our own sun is a late arrival to this long story. It formed from a cloud already enriched by countless dead stars. The dust that became Earth carried atoms cooked in suns that vanished long before our planet was born. The calcium inside your bones once glowed at the core of a giant star. The iron in your blood was forged in a stellar explosion. The oxygen you breathe was born in the bellies of suns that lived and died before our solar system existed. This is not poetry. It is simple chemistry. We are made of stardust because there is nothing else we could be made of. Every atom heavier than helium has a stellar address. Every breath is an inheritance. And if we are the first technological civilization, then we are the first arrangement of these old atoms to look back at where they came from. The first pattern of stardust to ask the question. The first knot of cosmic matter to wonder if there are other knots wondering too. That is a strange position to hold. It may not be true. It may be that countless other minds have already asked these same questions and gone quiet. It may be that we are one of many, just too far apart to hear each other across the dark. The honest answer is that we do not know, and may not know for a very long time. But sit just for a moment with the possibility that we are early, that the universe is still warming up, that stars will keep forming for trillions of years after our sun has cooled, that most of the worlds that will ever exist have not yet been born. In that picture, our small blue planet is not a latecomer to a crowded party. It is one of the first lanterns lit in an empty hall. Some thinkers find this lonely. Others find it gentle. If we are first, then nothing has been lost. The silence above is not a graveyard. It is a quiet room waiting. The atoms that became us are the same atoms that may, in some far future, become other minds on other worlds, around stars not yet ignited, in galaxies still gathering themselves from the cold. There is a thread that runs through all of this. The hydrogen made in the first 3 minutes after the beginning. The carbon forged in stars that died before Earth existed. The water delivered to our young world by comets and ice. The single cells that learned to breathe. The slow rise of nervous systems. The first eye that opened. The first thought that thought about itself. And now, somewhere on a small planet, in an unremarkable corner of an ordinary galaxy, a creature lies in the dark and listens to a voice talking about the stars. That creature is you, made of the same elements as the nebulae, carrying inside your body the ash of suns that lived and died before there was anyone to mourn them. You are a way for the universe to look at itself for a little while. Whether or not we are the first, we are part of the same story. The atoms in your hand were once inside a star. The light from distant galaxies has been traveling toward your eyes for longer than Earth has existed. The question of whether anyone else is out there is, in a quiet way, the universe asking itself if it has company. We do not have the answer yet. We may not have it for 1,000 generations. For tonight, that is all right. The question itself is a kind of warmth. It is enough to lie still beneath the dark and feel, gently, how old and how connected everything truly is. So we come to the quiet end of our long wondering. The question we have been holding tonight is one of the strangest a mind can hold. Are we the first? Not the first on our small blue world, but the first anywhere. The first eyes to look up. The first hands to build a telescope. The first voices to ask the question itself. We do not know the answer. We may never know it in our lifetimes. The universe is too large and too old and too quiet for any single generation to settle the matter. And yet the question has weight, even unanswered. It changes how we sit beneath the stars. It softens the silence. Picture for a moment a small planet turning slowly in the dark. Its oceans rest under a pale moon. Clouds drift in long white ribbons across its night side. A thin glow of cities traces the edges of continents, soft as scattered embers. From far away, this planet looks like nothing special. One pale point among billions. But on its surface, minds are dreaming. Minds are wondering. Minds are asking where the others are. That planet is ours. And tonight, as you rest, it carries you gently through space at speeds you cannot feel. The galaxy turns slowly around its hidden center, taking 200 million years for a single revolution. Our sun has made this trip only about 20 times since it was born. The Milky Way is patient. It is in no hurry. Beyond our galaxy, the others drift. Andromeda glows quietly across more than 2 million light years of empty space. The local group of galaxies floats together in the dark, held by gravity that whispers across distances the mind can barely hold. Further out, the great walls and voids of the cosmic web spread on and on, soft filaments of light woven through deeper darkness. In all that vastness, one possibility is that minds are common, and we simply have not learned how to listen. Another possibility is that minds are rare, and the silence we hear is honest. A third is that we are early, that the long night of the universe is only just beginning, and the great companies of thinking beings have not yet arrived. Each of these ideas has its defenders. None of them has been proven. The question remains open, and tonight that is enough. If we are the first, then something tender follows from it. The care we take with our small world matters more, not less. The kindness we show one another becomes part of a longer story. The knowledge we gather, the music we make, the questions we ask, these are not late additions to a crowded cosmos. They are early sparks in a quiet room. Someone, someday, far from here, may find the faint warmth we left behind and be glad of it. If we are not the first, then others have already learned what we are still learning. They have known long nights and long mornings. They have watched their own stars age. They have asked, as we ask, whether anyone else is out there. Perhaps they are still asking. Perhaps the silence between us is only the slow speed of light, carrying old letters that have not yet arrived. Either way, the sky above you tonight is the same sky, the same ancient photons, the same patient stars, the same soft glow of a galaxy that has been turning since long before your grandparents' grandparents drew breath, and will keep turning long after. Let your thoughts grow quiet now. Let the question rest beside you, the way a sleeping cat rests at the foot of a bed. You do not have to solve it tonight. No one does. The mystery is allowed to stay a mystery. The universe is allowed to keep its secrets a little longer. Somewhere in the dark, an ocean is moving under moonlight. Somewhere, a comet is drifting on a path that will not bring it near any star for 10,000 years. Somewhere, a nebula is slowly cooling into the shapes of future suns. The cosmos is not finished. It is only beginning. And you are part of it, small and warm and breathing, held by a world that has carried life for billions of patient years. Whatever the answer turns out to be, you were here. You wondered. You looked up. That alone is a kind of light. Rest now stars will keep their places. The galaxy will keep its slow turning. And the great question of whether we are alone will wait gently until you wake. Subscribe for a brand new space topic every night. One tap and something incredible is waiting for you tomorrow. Sweet